Welcome back. Exercise 8a, expanding binomial products. This won't be new. We've seen the distributive law before. We're going to look at it again and just look at what happens when we do something a little bit fancier. I bumped something silly there trying to hit draw because my pen has disappeared. I've changed my battery though, so with a bit of luck, we might not have as many glitches this time. Let's see how we go. Oh, pink, why not? All right, so all they're showing here is, if you know the rule already, if I have a number in front of two terms in brackets, the distributive law says, because that's multiplication, every term inside the bracket has to be multiplied by that term in front. So we get AB plus AC. An example of when you might do that is if I said, what is 2 times 43? Well, some of you will know the answer straight away, but most of us will work it out something like this. I've got 2 times 40 plus 3, and you work it out separately. You go 2 times 40 is 80, 2 times 3 is 6, and then you add them together and you go 86. Oh yeah, 2 times 43, 2 40s are 80, 2 3s are 6, 86. You've probably done that yourself, right? It's just what we're doing when we use the distributive law. Sometimes we might have two-digit numbers multiplied by two-digit numbers, and this would work. If I have 21 times 12. Oh, that's a bit annoying. Well, how could I make it easier? I could have 20 plus 1 multiplied by 10 plus 2. And you could go ahead and work it out this way. The 20 needs to multiply the 10. Well, that's 200. But it also needs to multiply that 2. Okay, that's another 40. That 1's got to multiply the 10. And the 1's got to multiply the 2. Oh, what's that? 252 when I add them all together. Now, you might not have expanded 12. You might have just gone 21 times 10. Oh, that's 210. 21 times 2. Oh, that's 42. 210 plus 42, 252. Whichever way you're doing it, you're using your distributive law. That's what we're doing. All you're going to need to remember for these is that each term in the first bracket multiplies each term in the second bracket. There are a number of little mnemonics and things, but they only work in certain situations. So I don't want you to remember anything other than if I've got a bracket multiplying another bracket, everything inside that first bracket multiplies everything inside the second bracket. You can see here there are a few different ways of doing it. You can draw arrows, which I've sort of shown there. You can use a box method to do it as well. I might show you a couple of those while I work through the 4 on the left. You'll have 4 to try, and then you can go ahead and do your work. Now you'll notice that they've messed up their typesetting here. Each of those should be double brackets. So first term in the first two terms inside the one bracket, and then the next two inside the second bracket. They've just had a bit of problem typesetting there. Here we go with A. X plus 3 times x plus 5. So, standard way of showing it for most students at this stage, you can draw the arrows or not draw the arrows. You just need to make sure each term multiplies every other term. Just check it off as you go. So x times x, that's x squared. X also needs to multiply 5, that's 5x. The 3 needs to multiply the x in the second bracket, that's 3x. And the 3 needs to multiply the 5, which would be 15. To tidy it up, collect your like terms. Like terms have exactly the same pronumeral form, so the x squared doesn't have any other x squareds to go with, so that x squared term's on its own. The x terms, there are 2 of them, 5x plus 3x, x all together, and then the constant term, 15. Constant term because it doesn't have a variable with it. Let's have a look at the next one. X minus 4, oh well, changing the battery seems to have had no effect, but that's okay. We will persevere. X minus 4, oh, we will struggle to persevere, multiplied by x plus 7. I'm going to talk you through this box method or lattice method. What we do is we break up this first bracket into x and negative 4, the two terms. The second bracket we can write on top there, x and positive 7. And now, to fill in each box, just multiply by the appropriate term. So x times x, x squared. This box over here, it's going to be x times 7. 7x. Here I've got x times negative 4, negative 4x. And negative 4 times 7, negative 28. Put them together. There's only one x squared term. The x terms, I've got positive 7 minus 4. So the result of that is positive 3x. Constant term, negative 28. So that box method's a really good one. Some of you will like to use it when you're going the other way and factorising as well, which we will be getting to. So it's handy to have seen it before, even if you don't necessarily need it. Part C, 2x minus 1 multiplied by x takes 6. Again, a slightly different way of showing it one more time. So we know the rule, everything in the first bracket has to multiply everything in the second bracket. So this 2x needs to multiply everything in the second bracket. And this negative 1 needs to multiply everything in the second bracket. So I can write it like that. 2x times x, 2x squared. 2x times negative 6, negative 12x. Negative 1 by x, negative x. Negative 1 times negative 6, negative times negative is a positive, so positive 6. Collect your like terms, 2x squared minus 13x plus 6. And the stylus continues to baffle me with its inability to work. You can see these computers are getting to the end of their lease. Alright, lucky last, D. What have we got? 5x take 2 multiplied by 3x plus 7. And once you practice at these, you can probably do them without drawing anything at all. Just go through. Oh, that's lovely. It's just, oh no, there it is. It's back again. So, take my first term, multiply the other one. 5x by 3x. 3 5s are 15, and x times x, x squared. 5x by 7, that's 35x. Negative 2 by 3x, negative 6x. Negative 2 by 7, negative 14. Collect my like terms. 15x squared plus 29x minus 14. There you have it. You've got 4 to try there for yourselves. Good luck with that. I'm sure you're going to be fine. If you've got any questions, you know where to put them in the collaboration space. Leave us a message in Teams as well if you're keen to make sure we see them sooner rather than later. Keep up the great work. See you next time, guys.